The ideas expressed in the following presentations are those of the speakers and do not necessarily reflect the views of ACI or its committees. ACI web sessions are recorded at ACI conventions or other concrete industry events and will be made available for viewing free of charge for 1 week. Thereafter, they will be archived on the ACI website or added to ACI's online CEU program, depending on their content.
My talk's going to be a little different because I'm essentially dealing with a lot of statistics, labor stats, and then how do we apply some of the technology to help expedite the process of construction and design. Again, my title is this end, a little typo in the book, just to give you an introduction. I got this title, Leveraging Advanced Technologies, essentially to stem the workforce shortages that we're experiencing. And I decided to change the STEM to make it all capitals to go along with the educational wording for it so that it kind of links. And that's really where we're headed. My learning objectives for today, and I have to kind of focus, I had to have a narrow focus because if you take all the marketing data, all the labor data, all the engineering data worldwide, it sometimes is flipped from what happens in the North American market. And so I wanted to be a little more focused because there's a lot of data out there I had to collect for some of these charts that I'm going to show you. But I'm primarily focusing on what's happening in the North American market versus engineering and construction markets. And there's dynamics going on. There's changes happening. What are those dynamics? We're going to discuss some of them. There may be more that you guys can fill in on as well because there are a lot of them. And then how can we effectively manage those changes and dynamics better using current or new technologies? And some of that's been discussed today. I will touch based on them, and you may have some technologies that you can share with the rest of the room as well when we get to the end of the presentation. Market force and the engineering force. The number of engineers in your workforce is dramatically being reduced. There are a number of reasons for that, but there's been a steady decline since about the 1980s. And the percent also in the field of engineering has also been reduced. Those that are staying with the field longer. There's a lot more transientness in the workforce, and we'll see that in later slides. So the percentage of engineers that have stayed with their career choice bachelor's is probably much greater in the 50+ range. I couldn't quite get a graph and a plot for that like I thought I could find, but collecting all that data, it's kind of hard to summarize it. But if you go down to 35 to 50s and to 20 to 35, you'll find there's a lot less people staying with their career choice through college now. They're making a lot more changes in their careers, maybe even out of engineering because they didn't like their first choice, or they found something better that might have paid better. They might go into management, might go into administration of a company because that's where their gifts are at. And so the engineering grads, the BSs, the MS, and the doctoral degrees by age, there's trends that are shown. And this chart right here, you'll have to bear with me. Business is in red. This is a plot from the Bachelor of Science degrees that are conferred since 1960 on this side up to 2008. Okay, so you've got business is the red, education is the green, social sciences is the purple, engineering is the blue, health services is the yellow. And you'll notice the trend in engineering, we went from second to last down to the bottom. And you'll also notice that from 1960 there's a little bit of a downward trend there, and then it bumps back up in the 1980s. And then I believe, again, since this thing has gone out, the focus more has been on the STEM education, and those numbers have started to rise or increase, but not as to the extent of the other health services or the other STEM, the other components of the STEM education. Science, technology, and math are accelerating a little bit faster than the engineering. And that's what we see in the trends. But what we also see is a little bit different in the advanced degrees. The advanced degrees are inversely proportional to this graph of engineers. Where in the 1960s there were few, it rose up in 1970, took a little dip in the 1980s, and now it's climbing fairly steadily. So the advanced degrees is actually following and inversely proportional to this engineering curve that we see for just bachelors, which is, I thought it was kind of interesting in the statistics. And the reason for that a lot of times too is because there's more women and minorities since the 1960s looking to get advanced degrees in engineering, which is good, but if you look around the room, there may not be that percentages that you expect in the STEM degrees going into engineering and then going into advanced engineering degrees. And that's part of them. So there's a slight increase, I said, since 2008 or 2005, when their focus on education kind of turned towards STEM. And then we also see another trend is, if you look at the statistics, is there's a slight decrease in the civil engineering degrees and a slight decrease statewide in the PE licenses that are conferred versus those that are retiring. So there's not a lot, the replacement gaps, there's still a widening gap there. And as I said, the diversity in the STEM careers is gaining. Is that happening in engineering? I think all you have to do is look at the ACI registration and see there's not as much as diversity in this group as there probably should be throughout the industry, as the percentages are, at least in the workforce. Are those trends alarming for us? Are those trends alarming for us as engineers, and how can we mitigate those trends or counter those trends using the appropriate technology? The construction market's another area. What's going on in the construction market? Well, there's fewer people entering that. There's also been same thing. Oops, let's go back. There's been a decline again since the 1980s or 1960s, even if you really follow the trend. So 60s, 80s, there's a trend moving away from construction, engineering, moving into other things, and we'll look at that. The workforce has been changing too. The skilled labor force, as the more populated, older guard retire, there's not as much workforce coming in, and they're not as well trained sometimes. And so you get problems on the workforce in construction, building or designing to what you have available in your workforce. And that skills transfer too, from the older to the younger. People want a lot more mobile application. They want to learn how to use that to be more effective in their jobs. There's been a steady decline in interest. Let's go on to the next slide. So this is the plot labor from 1840s on up to 2011. Okay, you see a lot of trends. This blue is in the service industry. The purple is in the manufacturing. The navy blue is in the agricultural, fishing, and natural sciences. The construction down here is this green one. And then you've got the energy sectors and the natural water resource management type sector as well. You'll notice that the population has increased in the U.S. since 1840s. But essentially, the construction market has kind of stayed flat. The blips in here based on, turnover and cyclical construction. And that's part of the problem of keeping the skilled workforce either in the manufacturing sector, as you see in 1960, and the construction sector active. You would expect, as the population increased, so would the construction percentage, or people going into the construction industry. And a lot of the reason is because technology has replaced a lot of those workers. There's been a lot of technology out there that has replaced them in the factories and the manufacturing points, or it's been outsourced somewhere else. There's also been better paying jobs in the service sectors, which has pulled a lot of those workers away, and they're more consistent. And there's also these generational and cultural issues and trends that factor into these charts. This is just a blow up of that same picture showing from 1960 to 2011, 2012. And you notice the service industry, manufacturing is coming down. Construction is pretty much staying the same, although there's a couple of blips when the construction industry dives or their funding levels are going out. And then you've got agricultural, and then they put this in as mining instead of natural resources and such. Why is the landscape changing? What are the factors in affecting the landscape? Well, better paying jobs in other industries is the key. So we got better paying jobs in these other industries. I'm going to go through a slide in each one of these now because there's individual trends of what's going on in the industry. So we've got the better paying jobs that are drawing people away. There's a code shift, and it's technically termed P2P, prescriptive to performance. Prescriptive is what we know has worked in the past. What is essentially, you get a recipe for a mixed design, you follow it, it gives you what you expect. And those are tried and true methods. A lot of times, especially where I'm in Oklahoma, you get a contractor, so well, that's how we've always done it. But I'm saying it's not the code anymore. I mean, building inspector wants you to build the code. I want you to build the code. I'm an engineer. I'm a practicing engineer. I'm not going to stamp your drawing. In fact, I got a project the other day. They had taken it to a certain level. They had records. They had pictures. They had lovely stuff. I reviewed it and I said, contractors taking it a little bit further than I can actually jump in on it without being held liable. I says, I gotta bow out of that because I don't want to put my PE license on liability for this project that I haven't had the initiation of trying to get in from the beginning. They had an architect, they had a contract, but didn't have a PE. And the state building official said you need a PE to stamp off the drawings. and they didn't go with that. So they went with the contractors thing, and the contractor's already way ahead of where I'm recommending it probably should have been. And so I said, I need to back out. So what else? Performance. We're heading towards performance. What is performance? Well, we're trying to get the best and the most out of your materials and your process. A lot of people refer to that as green. And I think the terminology you hear thrown around in green is just the method by which we're moving from prescriptive to performance. That's all it is. So you need to understand that, and when you understand that, you can put it in that package. That's the impetus. They're trying to move you from a prescriptive format to the performance of every material you might use in engineering, in building, and construction. And so there's also, with that, there's also this shifting of risk from the owner maybe to the contractor or the construction professional and the designer with this performance. So you've got to validate what your performance is and why. Okay, the spending issues. We're going through a phase now. ASCE gives some stats on what we need to fix the infrastructure, $3.6 trillion in 4 years roughly. The stats I think were given in 1915 to 2020. That's what they recommended for the fixing of the infrastructure. Well, there's a funding problem. We all know that. And there may need to be alternate sources for funding, but under performance, I believe under performance, if we do real true performance perspective, we can knock that down almost to 25% of the above estimate of 3.6. So you're now at 900 billion. And if you look at the U.S., what the U.S. wants to spend, this is about the number they're willing to fork out. Well, that's a huge difference. That's a huge difference. So this then has to come into play. We have to bridge this gap with alternate funding sources, private partnerships, bid, build, design, and operate, and maintain. So a contractor comes in, maybe he puts in a toll road. I mean, there's a lot of those going in a lot of places, and he's then required to continue maintaining that. He owns the road. He's essentially given license to the state to use it, but he still owns the road or still owns the management of it. And so that's part of the dynamics of the funding shift. Where are we going to get all those funds we need to actually build it, or how, can we do all of it under the performance criteria that we're trying to push in the industry? Material use. This is an interesting thing too, because worldwide, I can take this data and go worldwide with it. And since the mid-1950s, especially just I say in the U.S. market, concrete essentially has become the material of choice. And mainly worldwide because of its use, availability, and the initiatives and innovations that have been promoted on the world market. Okay, if you notice too, if you take a historical data, concrete is trying to do what steel did to iron at the beginning of the 19th century. Replace it as a primary building, and it's done a very good job. And that's what we're here, research, dissemination of information with ACI, and trying to push the best product that we can out there to be able to better build with the material of concrete. And we're pushing higher strength. Back in the 1960s, the best you could probably go is a 6,000. I was in a meeting in Toronto, and I think it was Toronto, but one of the ACI conventions, we're pushing 42 in a grout type mix, working with the material and trying to push where we can go with maximum strength. I think he said 42 KSI. Now, that sounded like steel to me, not concrete. I was blown away. Normal ranges of what you get for ultra high performance concrete is in the 30s now, but that's still equivalent to what iron ore was at the turn of the 19th century. So you see the shift in the trend. We're also going to longer spans, taller buildings, taller structures. You know, we're pushing the envelope now, trying to do what we can in performance-wise with concrete. Essentially, this last one, important. Essentially, we're trying to produce more efficient materials with using less. We're trying to push a more efficient material by using less material, which is the goal. And this is a plot. This is the U.S. tonnage market since 1900 to 2010. And you notice here, this is the 1950s. This is actually the components that make up concrete, gravel. This is the mining, coarse aggregate, sand, and gravel. So you see the percentage all of a sudden, it's increasing a lot more readily than this is the primary metals is here is the pink and the blue. This is the industrial mining material, and then you've got plastics and wood at the bottom. But you'll see that the components that make up concrete since about the 1950s has gone on this huge exponential thing. The other chart here is the scale of tall buildings, 1930s, 2010. and primary materials. The blue is steel, the red is concrete, the green is a composite, and then the yellow and the blue are mixed or unknown. You'll notice the trend from the 1940s at the maximum use of steel down to 2010, and this trend is actually continuing that way. Steel is only 21%. This is only for tall buildings. I believe the statistics is over 80 stories, which is 600-something feet. You'll also notice that this trend, because it's worldwide, this is a worldwide trend, that most of those buildings until recently have been built outside the U.S. And so the trend, because of concrete's availability worldwide, the trend is continuing in that way, and a lot of the taller buildings that are being built are now outside the U.S. in concrete. Now we return to the labor force, the dynamics that are changing the labor force. So this is a plot from 1900s to, again, 2010. And you'll notice that in the large percentage of the labor force around the turn of the century was men, 82% to about 18, roughly, depending on how you quantify the labor force back then. And this plot is kind of meant to be a little bit iffy, because it all depends on how you quantify the statistics. Back then and now, there's a huge variance of minorities, women in the marketplace, and men in the marketplace, what they do, what is a workforce back then even. So, but what you'll notice too is after World War II, there's a greater influx of women and a steady incline up that ladder. Somewhere between 1995 and 2000, both the population percentage and the workforce percentage flipped. Now there's more women. And there's also, with that, since World War II, there's also been an increase in minorities in the workforce. And the workforce, again, here has become more mobile, more transient. And that's due also to a lot of economic trends, dual family incomes, and things like that. So now we get to the latter part of my talk. This is just technology trends. I believe there's going to be an exponential growth in the expansion of the Industrial Revolution, and that is going to be in the use of technology, applied to a lot of different things, where we move, where we live, where we work, and how we go about our business. One of the most critical needs, and this is the nature of this thing, is in mobile technology. How is it applied? How it is used? How is it effectively managed? There's a lot of things. If I put up on the cloud, is it safe? If I put up on the cloud and I only give certain people rights to use it, can somebody hack in and steal that information? Is it proprietary? Those are a lot of the questions still that are being asked about mobile technology and its usage. How is it being applied? We got all this sorts of technology in our cars, in our factory and automation, in our homes and offices. A lot of technology going in. It's supposed to, again, make it better management, green it up, less energy use. Where's the trends that are going to help us out in the construction industry and design industry? Mobile technology, better communication, better research as well, and pushing that performance envelope and the guidelines that we want to do with the material of choice being concrete. Communication and collaboration are keys between office and field. Can you do everything you can do in the office and the field? Can you get real-time data on a device that you need to solve a problem in the field? I mean, sometimes that's key in keeping the construction or keeping the ball rolling in whatever you're building, whatever you're designing, and whether there's an RFI or there's a technical reference that you need to actually get. Can you get that real-time data on a device that you can move around with? So, and also telecommuting. Maybe more people need to be not going into the office, but working from home and sending in their work. And then we've talked about that. Many phone apps out there. Can they be useful in the field? Can they be useful in your workplace? So you're loading a program on your laptop. Can you do something else real quick on your phone? And then maybe even a quick hand count check. All three going on at once. Multitasking, because we need to do more. We need to learn how to do more with less. How can this essentially technology help us and apply to our industry? Doing more with less. Working smarter, not harder. Use this technology to help automate your systems. If you're working in a manufacturing plant, that may be key. Or prefabricate your products. And then, because when you prefabricate, it's essentially you get to the site and essentially it's assembly. It's a kit. It comes together. Again, mobile and field technology, communicating effectively with those two offices. And can you get that same tech in the field? Can you get the same tech you're using at your desktop in the field? What is our response? What can some of our responses be to effectively manage this is accelerate the construction process, accelerate the construction timeline with some of the technology that's out there. There is a program across the country called Accelerated Bridge Construction to help rehab the infrastructure a lot faster. And I plugged into that, and there's a lot of data out there on how to prefabricate things, put them in place a lot quicker, build a bridge in a weekend, because most of it's prefab before it gets to site. You just bring it in, plug it in place, replace the old, and now you've got a new, essentially, piece of infrastructure that should last 75, 100 years. There's a lot of ways to manage that. Prefabricated construction can help with that. Again, your material prep is all essentially performance guided. And so we're better using the technology that we have available to one to communicate and to design with. More options, again, for field conferencing. Can you then get all of the stakeholders together on one conference at the point of need, maybe at the site, at the location, and solve the issue right there without having to, I mean, sometimes it's hard to get all those three in a conference call together. And to better apply that technology where we need it most. What is available? And I've got a couple of examples of this. GIS, GPS type stuff. Can you get real-time data? I had an environmental consultant who was in Iowa. He needed location information of the property right next door to where my office was. And I said, well, what do you need? He says, well, I need this or this. What do you've got? And I said, just a moment. I went outside my USGS geological map on my wall of the quadrangle for where I work. And I said, wait a minute, I've got both of those on the sides of my USGS map. Either one of those would do for you. I have one on my compass on my phone. Just a minute, give me 10 minutes. I'll drive down to the site. I can access 3 corners. Would that be enough for your location? He said, absolutely. I said, just give me 10 minutes. I'll go out there and plot it. I got on the phone with him, hit my compass, read my bars at 3 corners, and I said, you're done. That's all you needed. That's an effective use of mobile technology I had on my phone already. And so I was pleased with that. In fact, during this session, I got 3 photos. We're doing a mock-up for a bending shape out of welded wire reinforcement for a cage of a variable height barrier on an interstate highway. And we needed to do a mock-up to see if the cage would fit right with my angles and my bends and everything. I got a phone call with 3 photos. I had to get out of the room just to make sure I can text back and say, yes, that's correct. Other applications. Can I get those access on a tablet, a handheld, or a wearable? Wearable is an interesting thing, I think, too, because I almost liken that to an NFL quarterback. A resident engineer on a large construction site may need to have a flip page, his plans on one, be able to video conference with somebody else from the office, maybe 2 screens split. So it's a curved screen computer. He might actually have to be the battery charger if you actually go off his body heat, because you can charge it for about a half an hour. There are programs, there are materials, there are batteries that can actually charge it off of body heat for about half an hour. So you need a real-time information on a site, video conference, plan on one screen, people and images on the other. You're transferring the message of the screen on back and forth. I imagine that could be something in place in a couple of years. The technology is there. Do we know how to use it and apply it? That's the question I have to ask. And then we talked about simple cell phone text. I talked about my compass. Can we get a U.S. geological map? Give me locations. Give me elevations, a rough elevation idea of where I am on my site. I mean, I can do that in terms of a level bubble on my compass, but that's about as far as I can go. I can't get elevation unless I plug it in to some other locational data and statistic. And then the phone apps. Can you use and apply in the field? My summary slide, summarizing these trends to help stem the gaps. There's a labor shortage. There's a knowledge-based skills transfer that needs to go on between engineering, construction, labor force. That's decreasing. How can we effectively do that and change it? There are codes and construction methods that are changing. How we apply those, how we manage those is critical to get a better product, to expedite the process. And the material use is changing. We're trying to do more with less. The labor force, though, is becoming more diverse. Is the engineering field. Are we keeping up with that diversity? Because we sometimes need those other questions, other people's responses in the industry to make sure we're managing effectively. And you do this a lot with civil planning. How is that managed? A building inspector, a city official may think something's different. If you give a presentation at a town hall meeting, they might say, well, we don't want to go in that direction. Well, you have to work with them sometimes and be able to come up with a plan that works for everybody in the community and can sign off on. How does that work? How does that manage? I like the other thing, too, is if you're out in the field and you actually want to dig a ditch, you may not be able to because you have to call call before you dig because you don't know what utilities are underground. If you can get a GPS or GIS, real-time data at that site, you won't have to call before you have to call somebody out to locate all your utilities. You'll know right then and there. And most large cities are going that way. Smaller cities, rural environments, that's a problem because you don't know what's underground. But if you can get the real-time data, hey, you don't need to worry about calling somebody else. You've got it right there. You know what's underground. You still might encounter a problem, but somebody has to sign off. But if you can call them, again, on the mobile device, get everybody on board, sign off on it, say, we're going to go ahead because we need to get this started, that's a huge impetus to get the project rolling and moving along. And that's some of the uses, using that technology better to fill the gaps in the moving the construction ahead and moving the design ahead and moving a lot of the things that we need in engineering to facilitate that infrastructure. And I think everybody has kind of noted also that one of the other statistics ASCE had in their vision, I think it was 2030, is that 85% of the infrastructure for buildings and construction for the population that's going to be existing in 2013 is not yet in place. I think that was a 2005 statistic or 2000 statistic. So in 30 years or 25 years, they were saying 85% of the buildings that need to be in place, the roads, the infrastructure, all that stuff is not in place now. Are we managing that correctly? Are we getting to that point where we can effectively accommodate the population we're going to expect at 2030? That's what we need to look at. Have you enjoyed it? Thanks for coming. Thanks for sticking around. Hope you enjoy lunch.
Cool.